Ready to explode with curiosity? In this video, we're about to open some top-secret doors to the world of fireworks and firecrackers, things you never even knew existed. Stick around, and you'll see how a simple blend of gunpowder turns into the magic behind the brightest blasts. You'll get the lowdown on the wild history behind their creation and the unusual secrets of master pyrotechnicians. This segment will get your heart pounding faster, trust me. Watch till the end, because the best part is still ahead. Stay with us all the way through, and you'll find out something that'll totally flip your perspective. Don't miss out. Firecrackers, they're the more hot-headed guys in this family. Their main trick? It's all about the sound, not the show. Sure, they're simpler in design, but they deliver the same kind of magic. Noise and pure adrenaline. Like fireworks, firecrackers use black powder as their base, but the approach here is a bit more straightforward. The key is nailing the right balance to get a powerful boom without any extra fancy effects. Typically, a firecracker contains a black powder mixture, a casing, and a fuse. We'll get into what's inside later, but for now, let's talk about the casing. It's usually a paper or cardboard cylinder that holds everything together. The material's gotta be strong enough to hold off the blast till the big moment, but not so tough that it creates dangerous shrapnel. The fuse is the most critical part. It sets off the entire explosive process. It could be a thin cotton wick soaked in chemicals or more modern ignition systems. How are firecrackers made? All the ingredients for the black powder mix are measured out with serious precision, then blended to get the perfect consistency. Accuracy is huge here. Just a little extra saltpeter can make the explosion go wild. Too little, and the firecracker won't ignite at all. Paper or cardboard tubes are cut to the needed length, then carefully loaded with the black powder mixture. These casings typically have sealed ends to build up just the right pressure for the explosion. At the top of the firecracker, a small hole is made for the fuse. The fuse is inserted and held in place with glue or a special sealant. The bottom and top edges of the firecracker are sealed tightly, often using glue or heat bonding. This ensures safe storage and transportation. Next, the firecrackers undergo careful testing. Manufacturers check the sound level, ignition speed, and quality of the explosion. Not all firecrackers are created equal. Cheap ones often have uneven filling, weaker sound, and a bigger risk of misfiring. They use lower quality materials, like plain paper instead of sturdier cardboard. High-quality firecracker casings are made from sturdy yet lightweight material. The black powder mixture inside is evenly distributed for a consistent effect. The fuses have a precise burn time to give you enough seconds to back off to a safe distance. Making firecrackers is no joke. Pyrotechnics plants follow strict safety rules. Workers operate in small crews, wear anti-static clothing, and handle only minimal amounts of mixture at any one time to reduce the risk of accidental explosions. Why are firecrackers so loud? This question comes up a lot. The deal is, a firecracker's explosion isn't just a chemical reaction. It's a massive release of energy in a confined space. When the powder burns, it releases hot gases that expand super fast, creating a powerful shockwave. And since the casing is tightly packed, that wave comes with the trademark boom sound we all know. The word firecracker comes from the French pétard, meaning a blast. Like fireworks, firecrackers trace their roots back to China. Initially, they were used to scare off evil spirits, and only later did they become a popular form of entertainment. Today, firecrackers are an essential part of many celebrations and festivals around the globe. But their history shows that even the simplest things can have deep roots and a fascinating evolution. So, the next time you hear that familiar bang, remember just how much skill, history, and technique is packed into each tiny firecracker. When it comes to making fireworks, you also start by mixing gunpowder with other components. If you think of gunpowder as the engine of the firework, then the other materials are the artists who create that explosion of color, light, and shape. To get bright sparks, you need metal powders like aluminum, magnesium, and titanium shavings. For vivid colors, you rely on metal salts such as strontium, barium, copper, and sodium. To boost the energy of the blast, you add ingredients like potassium nitrate, perchlorates, and charcoal. These act as oxidizers and fuels. And to hold it all together, you use binding agents, like water-soluble glues. Each component is first ground into the finest possible powder. Picture shining metal particles dancing in the light as the master prepares them for blending. These powders are so lightweight, it's almost as if they're suspended in midair, like some kind of magical dust. The most important step starts when the ingredients go into a mill filled with ceramic or wooden balls. These balls rotate gently, grinding the mix into a perfectly uniform blend. There's a soft rustle and a light tapping sound, kind of a subtle rhythm, reminding you that a future burst of colors is being born. As for mixing the ingredients by hand, at traditional production sites, this step is done with great care and reverence. Specialists slowly and carefully blend the ingredients with wooden or copper paddles. Why so slow? Because even a single stray spark could set the whole thing off. The mixture looks like a shimmering sand, where each component has its role to play. To avoid accidental explosions, the mixture is often moistened. Water doesn't just make the process safer, it adds a sort of mysterious alchemy, as gunpowder and colorants form tiny granules. The smallest mistake can cause a tragedy. You know what pyrotechnic masters do before they start working? They remove all metal objects, even wedding rings, to prevent sparks. In many labs, cell phones are strictly forbidden, and employees wear anti-static clothing. Even the air matters. Conditions are kept humid enough so that mixes don't dry out and become dangerously volatile. Before packing the mixture into the casing, the masters test how it burns. A small sample is ignited, and everyone holds their breath. Is that the perfect shade of blue? Are the sparks bright enough? It's like a dress rehearsal before the big show. Creating shapes and colors. That's the coolest part of production. Want a heart or a star in the sky? It all depends on how the stars are arranged. These are tiny pellets with a special composition. Where'd those brilliant reds, greens, and blues come from? All thanks to chemical compounds. For instance, barium makes green, strontium makes red, and copper makes blue. Once all the components are prepped, the next crucial step is filling the casing, where the heart of the future firework is born. It's right here that the explosive mix and colorants become a finished product, capable of painting the night sky in every color of the rainbow. The casing is a shell that holds all the fireworks parts together. It's made from special materials that can handle high pressure and heat, yet remain light enough to shoot into the sky. Cylindrical shapes are perfect for forming sharp patterns like rings, chrysanthemums, or peonies, while spherical shells create symmetrical three-dimensional effects, like a glowing orb exploding into hundreds of sparks. The filling process is super important, because the exact placement of components ensures the desired effect. Let's break it down step by step. First, you take cylindrical or spherical shells, usually made of cardboard, plastic, or specially treated paper with fire-resistant properties. Spheres typically come in two halves that will be joined later. It's crucial that the casing is airtight. That guarantees the explosion happens at the right moment with the right intensity. The black powder charge, acting as the main engine, sits at the center. It's responsible for propelling the firework skyward and making sure it explodes properly. Around that charge, the colorants and special effect mixtures are arranged. Each tiny star element is placed by hand or using special machines. These stars are what we call the pellets that burn in the sky. For spherical shells, these stars are placed evenly, so that when it explodes, it forms a perfect sphere of light. In cylindrical shells, charges are often laid in layers or formed into specific patterns, depending on the planned effect. One standard spherical firework can hold about 200 to 300 pellets. Large, multi-layer shells might have over 1,000 of them. To ensure the firework explodes at the right time, a time delay fuse is added, a small tube filled with a slower burning composition. This timer connects to the main charge, providing a delay between the rocket's launch and the burst in the sky. After all elements are in place, they're secured with a special paste or paper spacers. This keeps every component locked in position during the launch. The casing might then be wound tightly with string or glued for extra rigidity. Crafting one large professional-grade firework can take up to 4 hours, considering all the careful assembly and testing. For a massive show with several thousand shells, pyrotechnicians might work for a few months straight. The spherical shape is the classic standard in pyrotechnics, giving an even spread of stars and creating that perfect circular effect. Filling such a shell requires even more skill. Each star is placed by hand around the central charge. It's all on the master's shoulders. How the components are arranged will define how the explosion looks. For example, to create a smiley face in the sky, the pellets are laid out in the shape of a face. When the powder ignites, those pellets spread out just right, forming the intended pattern. Every year, over 200,000 short tons of fireworks are produced worldwide. China is the leader here, accounting for about 90% of the global output. For major holidays, like Independence Day in the United States or New Year's Eve in Sydney, up to 10,000 separate fireworks might be launched in a single night. Such a display can last over 20 minutes and sometimes costs as much as $5 million. Despite the beauty of fireworks, safety stats are pretty alarming. In the United States each year, up to 10,000 injuries are reported due to improper use of pyrotechnics, with about 70% of the injured being young people under 20 years old. Sell 100 million pairs of shoes in a year? What kind of production can pull that off? You won't believe it, but Crocs did just that. Today, we're gonna walk the path of the world's lightest footwear, from a polymer bead to a cult favorite. And from that cult, we'll move on to recycling these shoes. Crocs was founded in 2002, and their products instantly took over the world. The manufacturing process of Crocs is pretty complex. It all starts with the raw materials. They're the key to Crocs' success. The material they're made of is called Croslite, a patented foam resin that provides lightness, comfort, and durability. It's not just rubber shoes like many people think, but a special closed-cell foam material. Croslite is a type of ethylene vinyl acetate, a polymer material that boasts water resistance, cushioning properties, and high wear resistance. Polymers for Croslite are produced from oil or natural gas, which are processed into polyethylene. Large chemical enterprises located in Asia, Europe, and the USA supply this raw material to Crocs factories. The raw material is transported in the form of pellets. They're easily shipped in large containers and stored in dry conditions until production begins. The main Crocs manufacturing factories are located in Asia, Vietnam, China, and Indonesia. These countries have access to affordable labor, large volumes of raw materials, and robust logistics. The name Crocs comes from the word crocodile, because these animals can live both in water and on land, just like these shoes. Now, let's head over to the production line, bro. Check out how these guys load the pellets into a special machine where they're heated to high temperatures. It's seriously hot. The melting temperature of the material reaches 400 degrees Fahrenheit. The material melts and becomes liquid, resembling thick cream. The liquid polymer is poured into special molds that shape the shoes. The molds are subjected to high pressure, ensuring all the details are filled tightly. Excess polymer oozes out under pressure from the mold, kinda like creme brulee. If it weren't for the smell in the factory, you'd be tempted to take a bite, right? But it's definitely not something edible. As it cools down, the material expands, creating Croslite's unique closed-cell foam structure. This provides lightness, elasticity and softness, water resistance, and antibacterial properties. The shoes weigh on average only about 5 to 7 ounces. Confess it, who's gonna run off to weigh their Crocs after watching this video? But let's keep going, bro. Shoes made from these amazing pellets don't absorb odors and are easy to clean. But all this happens after they're taken out of the mold. That's when the excess material is trimmed off and the edges are smoothed. Look how quickly and precisely these guys work. The surface is polished to avoid burrs or roughness. It takes less than 5 minutes to produce one pair of Crocs. After trimming the excess material from the mold, the cut edges are treated with grinding machines. This is done to remove sharp edges, burrs, or irregularities left after trimming. First, they use abrasive belts or discs with medium grit, which quickly remove large irregularities. Rotating grinding tools allow the edges to be processed evenly and replicate the shape of the sole and the upper part of the Croc. Then, the workers move on to fine polishing. To ensure the surface is soft and smooth, they use fine grit abrasives like sanding sponges. This stage removes microscopic roughness that could cause discomfort when wearing. For particularly sensitive areas, like the edges of the ventilation holes, they use hand tools, like sanding sponges or polishing pads. Hand polishing guarantees the absence of even the smallest burrs. In the US, the military uses them as shower shoes because they're water-resistant and dry quickly. Other elements are added to the finished shoes, namely straps and gibbets. The straps for securing are attached separately. They're made from the same material or from more rigid polymers. Rivets are installed on the straps, allowing them to move. What kind of gibbets do you have, bro? Gibbets are decorative accessories that attach to the ventilation holes of Crocs. They allow you to personalize your shoes by adding elements that reflect your individuality, hobbies, or even mood. The idea for decorating Crocs came about in 2005. It was invented by Sherry Shubitsky, a mom who, together with her kids, came up with a way to adorn Crocs with tiny plastic charms. Let's all write in the comments, "Thank you, Sherry." Sherry used regular decorative buttons that her kids attached to the ventilation holes on their Crocs. The idea was so popular among friends and acquaintances that it eventually turned into a full-fledged business. In 2006, the Crocs brand bought the idea for $10 million, adding gibbets to their official product lineup. Gibbets are small decorative elements made from soft plastic or silicone. They have unique shapes and a special fastening mechanism. Gibbets can be in the form of symbols, emojis, logos, favorite movie characters, animals, plants, inscriptions, and so on. The back of the gibbets has a small stem or pin that fits into the ventilation hole of the Crocs. Thanks to the material's elasticity, the gibbets easily inserts and holds very securely. First, designers create sketches of future charms. These can be popular symbols, current memes, or seasonal themes. For example, snowmen in winter or sunflowers in summer. After the design is approved, three-dimensional models are created, which are used to form production molds. Liquid plastic or silicone is poured into molds with detailed designs. After cooling, the material solidifies, retaining the shape of the charm. Simultaneously, the back fastening part is formed, ensuring a secure connection with the Crocs. In 2021, a unique gibbets was sold at auction for $10,000. It was made of gold and adorned with diamonds. As for coloring and applying patterns, various techniques are used here, as you can see. Color is added at the stage of melting the pellets so that the color is evenly distributed throughout the structure. And to create print, they use laser engraving or printing techniques. Each pair undergoes quality checks for compliance with shape, color, and absence of defects. If defects are found, such pairs are discarded or sent for recycling. And that's the end of the production cycle. The finished Crocs are packed into boxes and transported by sea containers or by air to warehouses around the world. Crocs are comfortable shoes, but they present an environmental challenge. The Croslite material isn't a traditional plastic. At the same time, the Crocs brand is making efforts to make its products more eco-friendly and to find effective ways to reuse old shoes. The patented foam material doesn't decompose naturally, so if you throw out old Crocs, they can remain in landfills for decades. Croslite doesn't lend itself to standard plastic recycling methods due to its unique chemical structure. Recycling requires special technologies that most waste processing facilities don't have. You get it, bro. They invented a unique, durable material. But now, the problem is what to do with it afterward. In the past, Crocs implemented a program to collect old Crocs. They disinfected, refurbished, and passed them on to people in developing countries. So, we're cluttering up not our own country, but those who don't have a choice. Controversial idea, huh? That's why the program was discontinued, but it inspired the creation of new eco-initiatives. In some Crocs stores, you can leave your old shoes, which are sent for research into reuse or for conversion into energy resources. Today, old Crocs are sometimes used to obtain energy through the process of pyrolysis. Croslite is burned in special furnaces, and the energy obtained is used for heat or electricity production. Admit it, that's a pretty good look. Also, after shredding, old Crocs can serve as the basis for new materials, such as rubber coatings for playgrounds, insulation material, or as construction or decorative elements. Sushi that rivals top-tier restaurants ready in just minutes? Imagine machines crafting thousands of perfect rolls every hour, with rice of flawless consistency forming the base of nigiri. We're here to unveil the secrets behind automated systems that transform tons of raw ingredients into true culinary masterpieces. Curious about how sushi is made for supermarkets and restaurants? Stay tuned to find out. It all starts with rice. As the cornerstone of sushi, cooking it properly is one of the most crucial steps. In large sushi restaurants and production facilities, high-capacity rice cookers are used, capable of handling between 22 and 66 pounds of rice per cycle. These cookers ensure precise control over temperature and cooking time, producing rice with the perfect consistency every time. The second key ingredient is fish. In the United States, most sushi operations rely on frozen fish, especially salmon and tuna, to meet FDA requirements for parasite destruction. Rapid thawing systems maintain strict temperature control, preserving the fish's texture and flavor. These systems can defrost up to 1,000 pounds of fish per hour. Fish slicing machines are equally impressive in their efficiency. Some models can cut up to 1,000 pieces of fish per hour with remarkable precision. Automated blades adjust slice thickness, allowing for customization depending on whether the fish is destined for nigiri, rolls, or sashimi. Filleting machines also play a vital role, expertly processing fish to reduce waste and ensure uniform pieces. These machines can handle up to 200 fish per hour, significantly reducing prep time compared to manual labor. Vegetables like cucumber, avocado, daikon radish, and others require careful preparation. Modern vegetable washing machines can handle up to 660 pounds of produce per hour. These machines effectively remove soil and contaminants, ensuring sanitary conditions are maintained throughout the production process. Vegetable slicing machines allow for rapid cutting into thin strips, cubes, or slices. For instance, thin cucumber and avocado strips are essential for rolls. These machines can process up to 220 pounds of vegetables per hour, producing perfectly uniform pieces that contribute to sushi's consistent appearance. Once prepared, vegetables are stored in specialized refrigeration units with automatic humidity control to keep them fresh throughout the day. This is particularly important for avocado, which oxidizes quickly and can change color if not properly stored. Nori, or pressed seaweed, usually requires minimal preparation, but specific protocols help keep it fresh and crispy. Large sushi production facilities often use special low-humidity storage containers to prevent nori from becoming soggy before use. Some automated sushi-making systems even include machines that cut nori to the exact size needed for various types of sushi, streamlining the process further. Infrared and optical scanners are used to check the quality and freshness of ingredients. For example, these scanners can assess the freshness of fish by measuring moisture levels and the color of the flesh, helping to identify substandard products before they reach the production line. All ingredients are stored at optimal temperatures. For instance, fish is kept between 30 and 28 degrees Fahrenheit to maintain freshness. Automated refrigeration systems monitor and record temperature data in real time, ensuring consistent storage conditions. The automation of ingredient preparation significantly reduces the time needed to ready products for use. Thanks to these technologies, a large sushi restaurant or production facility can process up to 4,000 pounds of ingredients daily, guaranteeing both freshness and uniformity in every sushi portion. This not only cuts labor costs, but also improves sanitary conditions by minimizing direct human contact with food. Have you ever tried making sushi at home? I have. I bought the fish, cream cheese, even a special rolling mat. Watched a few YouTube videos, feeling pretty confident. After a few hours of trying to put that newfound knowledge into practice, the result? Let's just say it was very homemade. You know what that means. Delicious on the inside, but hilariously amateur on the outside. And don't forget the hours spent on it. What did I learn? Never again. I'll stick to ordering sushi delivery. It's my true love. Before cooking, rice needs to be thoroughly rinsed to remove excess starch, which can make it overly sticky. Industrial rice washing machines can process between 110 and 220 pounds of rice per hour. Some models allow for adjustments in the intensity and number of rinse cycles to achieve the perfect texture. Each rinse cycle takes about 3 to 5 minutes, which is significantly faster than manual washing. These machines also regulate water usage, helping to minimize waste. After washing, the rice moves to specialized industrial rice cookers, which automatically control the temperature and cooking time to ensure the ideal consistency. A single cooking cycle lasts between 45 minutes and 1 hour, depending on the rice volume and machine capacity. The cooker carefully manages the heating process, starting with cold water and gradually warming it, allowing the rice to cook evenly. Most rice cookers operate within a temperature range of 194 to 210 degrees Fahrenheit. Once cooking is complete, some models can keep the rice warm for several hours, ensuring it remains ready for use throughout the day without compromising quality. After cooking, the rice must be seasoned with a special mixture of rice vinegar, sugar, and salt, which gives it the distinctive flavor needed for sushi. On industrial kitchens, this step is also automated to ensure a consistent taste in every portion. There are specialized devices that automatically distribute rice vinegar, adjusting the amount based on the weight of the rice. For instance, approximately 17 ounces of vinegar are typically used for 22 pounds of rice. The rice is then mixed using specialized mixers that cool it and maintain the optimal temperature to prevent excessive clumping. The rice is usually cooled to around 100 degrees Fahrenheit, which is an ideal temperature for forming sushi. Once prepared, the rice is kept warm in specialized containers that automatically regulate the temperature to prevent it from spoiling too quickly. The sushi shaping stage is the final step in the production process. In large-scale American facilities that specialize in mass-producing sushi for supermarkets, restaurants, or delivery services, this process is highly automated. This automation ensures high productivity, consistent quality, and precise portioning, almost like modern-day samurai. The process begins with preparing the rice bases that serve as the foundation for nigiri, rolls, and maki sushi. Nigiri machines can automatically form rice balls of uniform weight and size, ensuring accuracy in every serving. For instance, automated nigiri machines can produce rice balls weighing 10 to 15 grams each, which is the ideal weight for easy consumption. Some of the latest models can produce up to 4,000 pieces of nigiri per hour. These machines guarantee uniform shapes, reducing the risk of sushi falling apart during serving or packaging. Additionally, they provide perfect rice compression, ensuring that each piece has a consistent density. For various types of rolls, such as futomaki, uramaki, and hosomaki, specialized machines are used to automate the rolling process. These machines distribute rice evenly over a sheet of nori, apply the filling, and then roll it all together. The system is calibrated to ensure the rice covers the nori evenly, with a thickness of about 5 to 8 millimeters, depending on the type of roll. The machines can also automatically add fillings to the center of the roll, precisely controlling both the quantity and placement. The amount of fish, vegetables, or avocado can be adjusted to within a gram for each serving. Once the roll is formed, cutting machines take over. These machines are equipped with ultra-sharp blades that slice the roll into 6 to 8 pieces without squashing or deforming it. The system adjusts the thickness of each slice to ensure uniform height, typically around 1 inch per piece. Some machines even feature a self-cleaning function for the blades after each roll, preventing rice buildup and ensuring a perfect cut every time. Now, that's the kind of knife I'd love to have at home.